Welcome back to the Rule Your Pool podcast. I'm your host, Eric Knight with Orenda and Hasa. This is episode 136. We have a lot of blogs, and I've been going back into the ones that I was writing back in 2016 and 2017 when I just got started and really didn't know much yet. And I'm updating them. And one of those subjects reminded me that a listener, one of our early listeners, requested something to our email address, podcast@orendatech.com. And they asked about this thing called ORP, Oxidation Reduction Potential. What does that mean? That's what we're going to talk about today. So without further delay, episode 136 of the Rule Your Pool podcast, Understanding ORP. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. On this show, we talk a lot about two disciplines in water chemistry. There's water balance, which is just physics, like the LSI and Henry's law. And that's the majority of what we talk about on here. But today we're talking about the other side of water. And that's water quality. See, water balance is all about water returning to its natural state. Water quality is what we do to water. It is unnatural for water. Disinfection, oxidation, safe, clean, clear, all that stuff. The chemicals we add, the secondary systems we put in. We are trying to optimize water because the number one priority in pool care is disinfection. We do not want people getting sick. We want this water to be safe to get into. If there's accidental ingestion, and I will tell you, as a swimmer, sometimes we swallow water. Doesn't matter how good of a swimmer you are, it happens. Certainly water's in and out of your mouth constantly as you breathe. I'm not saying it's intentional, it's certainly not, but it happens. It's all over our skin. Skin absorbs stuff. So making sure that chlorine or whatever your sanitizer is optimized is really important because we want to make sure that that water is safe. And ORP is a measurement in real time of how effective your primary oxidizer in your pool is. I'm going to try to simplify this down because it is complex. Technically, ORP is a thermodynamic thing, and I really tried to come up with analogies so you can visualize it. I know they're not perfect, but they get the concept across enough that hopefully it can be understood. There's a helpful acronym, and we talk about this in Orenda Academy 4 Pillars. I think it's in Pillar 2. It's an acronym OIL-RIG. It stands for oxidation is loss, reduction is gain. I want you to imagine that you have this object in your car or wherever you are, and you are chlorine. You're an oxidizer, and you need to oxidize that object. In my case, I'm looking at a pair of sunglasses on my desk. If I'm chlorine and I want to oxidize my sunglasses, I want to steal an electron from those sunglasses. Oxidation is stealing an electron from something. Oxidation is loss. Those sunglasses lost electrons because I stole them, and then I get reduced by gaining those electrons that have a negative charge. So reduction is gain. It might sound backwards because oxidation is loss, reduction is gain. How can I gain if I reduce? I'm gaining something that has a negative charge. Electrons have a negative charge, which reduce my valence. They reduce my charge. That's what that means. So when you say chlorine gets reduced, what you're really saying is it pulled electrons and it's not HOCl anymore. It's now chlorides. It's been reduced. Its charge is down. But it's not just that. In most cases, I have to give something back. So what I'm going to do is I'm going to swap my oxygen, hence the word oxidation. I'm going to give it my oxygen and oxidize those sunglasses as I take that electron. This transaction that I just made has to happen together. Okay, you can't just have something lose electrons and have them not go somewhere. Anyway, enough about that. So why is it used in swimming pools? That's the real question. ORP is awesome because it gives you a real-time reading. You don't have to just test it every couple hours if you're commercial operators or if you're a pool pro that shows up to a backyard pool and you're basically testing once every 7 days. You don't really have a real-time picture at all. ORP is that real-time picture. And just like a digital pH probe, you can track it. You can know exactly how things changed over time if you have software that does that. I know fancier commercial chemical controllers will do this. They have softwares and apps on your phone, and you can look back at, wow, there must have been a swim team practice because my ORP dropped at 3:00 p.m. Oh yeah, that's right. The swim team jumped in at that time. And by doing this, you can actually gauge chlorine's burden, I guess. It's better for measuring chlorine demand, so to speak, than just chlorine performance. So you can look at it either way. And I was trying to come up with an analogy of this because for years, I used to teach that ORP was like a speedometer for chlorine. Like how fast does it do its job? And that's kind of true. It's certainly easy to visualize, but I think there's a better way of looking at this because technically ORP is a thermodynamic reaction. It's not a kinetic one. But for simplicity, this visual analogy is helpful, at least in my mind. Imagine that chlorine is a car. ORP is not the speedometer in your car. It's not how fast you can go, and it's not how fast you are, like you could be a Ferrari. It's really more the quality of the highway. So it's the potential of how fast you could go. So if I am in a regular car on an open highway with no traffic, straight shot, I'm going to go faster than that Ferrari in the West Virginia hills on a gravel, bumpy road. That's kind of how I look at ORP. It's the potential for how well chlorine can perform. And it's not the same thing as conductivity. Conductivity is how fast electricity can transfer through water. These are super similar because we are talking about electron transfer. The difference is ORP is a type of conductivity, but it's specific to an oxidation redox reaction, not something like electrolysis, for instance. So how is it measured? Well, similar to conductivity, it's a digital probe that is submerged in water or whatever solution you're testing, and they're typically made of noble metals that are highly conductive, like gold or platinum. Electron transfer reactions occur at the surface of these metals when that solution contains an oxidizing or reducing agent. So if chlorine is in there, it's going to react with that metal, and it's measuring the voltage that's touching it. I'm putting myself to sleep. I hope you're still awake and not driving. Let's talk about a few things that affect ORP. What can reduce ORP? What impacts it? Or better yet, are there things that can trick ORP? Are there things that can suppress it? We want ORP to be higher because it tells us that, hey, chlorine's kicking butt and it is ready to kill whatever gets in that water. If it's lower, chlorine's got a lot on its plate. Try not to overload the pool now because it might fall behind. We want good performance of our chlorine and our oxidation. The higher the number, typically the better things are going, the safer the water. Let's see my notes. I have 4 things that directly affect ORP. 3 of them are the main ones. One of them is kind of misunderstood, but we got a pretty good theory on it, and chemically it makes sense, so we're going to talk about it. The first one is pH. The second is cyanuric acid. And the third is water temperature. The fourth thing is something having to do with salt chlorine generators. So let's get through it. Let's start with pH. ORP is highly sensitive to the pH of the water, with or without cyanuric acid. Now, I know in many episodes before I've explained that once you introduce CYA to the water, the concentration of HOCl, the active form of chlorine, goes way down. And that's still true. I'm not recanting anything we've said. That's absolutely true. But the thing about this is, even with CYA in the water, pH still has a direct impact on ORP. And this is going to be hard to explain, but if you go onto the Orenda app, go to blogs in the main menu, search ORP, or go onto orendatech.com, search ORP, and you'll find this article, Understanding ORP. There's an equation in there. And on the left side of this equation, HOCl and hydrogen ions are on the same side. The reason it's important that the hydrogen ions and the HOCl are on the same side is that if you increase the concentration of HOCl, ORP goes up. Or you can increase the concentration of hydrogen ions, ORP will still go up. Or you can increase both. Even if you have CYA and you have a very low concentration of HOCl, if you increase the hydrogen ions by lowering the pH, your ORP will go up because they're on the same side of the equation. You don't want to have a pH that goes sky high. And before going further, we have talked ad nauseum in many other episodes about how to limit how high that pH goes using the pH ceiling. because it's going to go there, especially if your pool is serviced once a week. You're showing up every 7 days. It's going up over 8 anyway. What we want to do is we want to limit how high that goes so that it doesn't go into the 8.2s and especially over 8.3, because chlorine starts to break away from CYA and it gets zapped out by the sun. And you're not going to be able to hold chlorine for a week. So by utilizing Henry's law, we can limit how high that pH goes. But that's on a residential pool, not a commercial pool. Commercial pools have 24/7 monitoring, they have 24/7 chlorination, and they have 24/7 ORP and pH. So they are regulating the pH differently because of health departments, which is fine. Especially if you're using ORP, you want to regulate the pH. But how do we do that affordably? We've probably talked about it before, but you might want to use Henry's law to your advantage and buy yourself some time between acid feedings. Namely, use a little less alkalinity, rely more on calcium so that your pH rises slower, because you're still going to try to keep your pH consistent. But why not slow down between the acid treatments so you're not burning through all this alkalinity and all this bicarb that you now have to replace, and limit that, save a whole bunch of money, and maintain the pH where you need to be. Just a thought. Before recording this, actually a while ago, I was speaking with Richard Falk, who we cite all the time on our website because he's a water chemistry genius. And he was explaining ORP in a way that I had never heard. He said, for ORP to be helpful and relevant to the pool operator, it must be correlated with a known free chlorine level, or a free chlorine to cyanuric acid ratio level, at a fixed pH. Think about that for a second. On a backyard pool where your pH rises, with aeration and all that stuff, if you don't have an acid feeder, ORP is not going to be necessarily an accurate measurement until that pH gets back to whatever the set point was. It doesn't mean your chlorine is less effective. It means the ORP is based on a fixed pH. If the pH moves, the ORP is going to change. But like I said, that doesn't necessarily change your concentration of HOCl very much. So it's kind of deceptive that ORP is based on a fixed pH at a fixed chlorine level. If you don't have chemical automation, it's not really telling you much because those factors are changing. Still nice to have, I guess, but it should be used in conjunction with a chlorine feeder, for instance. For commercial pools, especially indoor commercial pools with no cyanuric acid, they are using chemical controllers to try to suppress pH consistently enough that it stays relatively stable. Of course, it's never going to be perfect, but it's the best they can do. So say that pH is 7.5. Every time it goes up, it just trickles a little bit of acid in. Hopefully it's using something like a proportional feed, and it's trying to keep that pH steady. It is also feeding chlorine to try to keep that level steady. Is it perfect? No, it's not perfect. But the set point for ORP was based on those numbers. So the further you stray from those numbers, the more distorted the ORP is going to appear. Okay, enough about pH. Let's move on to cyanuric acid. Cyanuric acid lowers the concentration of HOCl dramatically. Therefore, there's less active oxidizer in the water until that active chlorine breaks away from CYA to do its job. So it's still in the water, but the concentration of HOCl goes way down. We have this in the article. It's that same chart that if you're on the Orenda calculator, you tap CYA because it's underlined. By the way, everything underlined in the Orenda app is a hyperlink to open a pop-up and educate. Look at that chart, and you will see the red line is pretty much at the floor. That's why. So the more CYA you have, the lower your ORP will read. But that's not necessarily entirely proportional. And the reason for that is, yes, the ORP reads lower. But as we said before, if you have a good free chlorine to cyanuric acid ratio, you could still have effective disinfection. The difference is your ORP is not picking it up. The third thing is water temperature. Now, since ORP is a thermodynamic measurement, water temperature matters in every chemical reaction pretty much that we deal with in pools. The colder the water, the slower things happen, and you're not going to have nearly as efficient oxidation or reduction. Therefore, the ORP goes down. Conversely, the warmer the water, things speed up, ORP goes up. Now, the last thing has to do with saltwater pools. If you have an ORP system on a saltwater pool, you may have noticed that the ORP tends to get suppressed, like dramatically, but only when that salt cell is on. You might be thinking, how is that possible? My salt cell is producing chlorine and my ORP goes down? Well, you're right. That shouldn't happen. So we have a theory on this, and chemically it makes sense, although it has not been proven per se, at least not that I know of. Here's the theory. Remember, your salt system is producing chlorine gas, sodium hydroxide, and hydrogen gas. And since hydrogen gas, H2, not hydrogen ion, hydrogen gas, H2 is not very soluble, so it bubbles up, it creates turbulence, which forces CO2 out of solution and raises your pH. Remember all that? That hydrogen gas blows into the pool and may, in certain cases, depending on the plumbing and all that, may get back into the circulation system. And if those hydrogen gas bubbles come in contact with that platinum or gold ORP probe, there's going to be a reaction there. It'll interfere with that probe, and that will depress the ORP level. Again, this has not been proven definitively, but it makes a lot of sense because you're basically deceiving the probe. That's what we believe ORP suppression is all about. Not much you can do about it if those hydrogen gas bubbles are getting back to the probe. So anyway, we'll wrap up here with some ways to increase the ORP. So if your pool is struggling, what can you do about it? Number one, you can increase your chlorine levels. The more free chlorine, just by sheer volume, the more HOCl is going to be present. You can lower the pH because the pH, regardless of CYA, is still going to increase your ORP if it's lower because the hydrogen ion concentration goes up. You can enhance your circulation. Improving circulation can distribute chlorine more evenly. It can increase its effectiveness in sanitizing the water. Remember, the holy trinity of pools is circulation, filtration, and chemistry. Circulation rates can be increased. You can improve filtration, which can take more particles out of the water, which could potentially be oxidants. You can supplement your chlorine against the oxidants, pillar number 2. You can get oxidants out. You can manage the metals. You can avoid putting nitrogenous compounds in your water, like quat algicides or anything that contains ammonia or ammonium. All those things will combine with chlorine and take a lot of chlorine to get rid of. If you avoid putting nitrogen in your water, there will be less oxidants. Therefore, ORP will go up. Enzymes are very good for non-living organics. These hydrocarbons and oils and greases and sunscreen, lotions, makeups, all that stuff. Chlorine is not made to get rid of that. Enzymes are. So you take those out of the solution, hey, water is a lot easier to manage. And it's going to increase your ORP indirectly. It's not that any of these things are going to accelerate oxidation for chlorine. It's more like it's going to remove things that chlorine would otherwise have to handle. So therefore, you have more of it ready to go for what you really need it for. Then finally, minimize contaminants. You can regularly remove leaves, grass clippings, things like that. If you, like me, have a lot of leaves getting into your pool and you just leave them in there because you're out of town all the time going to trade shows, you're going to have a lot more oxidants in your pool. So what can you do? You can net them more regularly. If you're a homeowner listening to this, be proactive between your weekly service professional showing up if you have one. Clean the skimmer, things like that. Just get things out of your pool. Remove complexity. Most pools that have ORP are commercial pools. They're public pools. You got to manage the bather load. That's the biggest thing. What can you do to reduce the demand on chlorine? I'm not saying reduce the bathers, but what can you do to reduce the bather load? Showers before swimming can be helpful. Enforcing bathroom breaks, although good luck with that with a swim team. I can tell you from experience, culturally, a lot of changes are going to happen for that to work. But you can minimize what gets into the pool. Don't use cleaning products on your deck that contain ammonia, things like that. How can we reduce the burden on chlorine? That's the name of the game. And if we can do that, then we can increase our ORP. Anyway, I know this was complex. I hope I wasn't too repetitive on this episode, but I'm glad I got to record this outside. I've enjoyed this. And by the way, doing this podcast is the highlight of my week, though I haven't been able to do it every week. It's a lot of work, but I want to express once again how grateful I am personally that you are still listening to this, that you find value in it. I hear from you. I've met so many of you at the trade shows this year. I know most of you probably don't have ORP systems, But for those of you who do, I hope this helps. And if you know pool operators that operate public pools, share this with them. Hopefully it helps them understand better what that number means next to their pH. I'm Eric Knight with Orenda. This is episode 136. And I don't know what we're talking about next time, but look forward to talking about it with you. Thanks.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.